VLPSos here. This is a video lesson for Python programming, the math module. These lessons are intended to be paused so that you can practice. Python has a standard library of functions that comprise the core language, like print. We can add more functions to the language by importing them. We can write our own functions to be imported. More on importing in future lessons. The print function is very common. Idle colors the name print and identifies it as a keyword of a function that is in the standard library. There are functions that other people have written and have made contributions to the Python language by providing them to people that use the Python language. The Python language doesn't include all of the possible functions that can be used in Python all at once. It's divided the language into chunks, and we call the standard library the palette or the collection of functions that are most common and most useful for most programming, especially basic programming or simple programs. And the reason why the language is divided into chunks is because when we compile a program, when we turn our code that we've written in a text file into a program that can be executed on a computer, we don't want it to be too cumbersome of a process. We only want to add pieces of the language or the capability of the language that are going to be used in a program so the entirety doesn't become unwieldy and take up a lot of memory and space on our computers, both when we craft programs and when we compile them for distribution. There are a variety of functions, math functions, that are part of the standards library, but there are more sophisticated math functions that we will need to add a module to our language in order to have access to. And we do that with importing. So when I write import, it knows that the word import is a keyword, that's why it's colored. Math is the name of the module, and the math module, all those functions are on my computer drive waiting to be attached to the ones that I have available. And that import statement allows that to happen. There is a lot of basic math that can be done without needing the math module, without needing to import, or even to use a function because they have an operator symbol. Math is a little unique as a function because it's so fundamental to numbers that we have symbols that do the same thing as a math function. And here is a variety of basic math operators in use in a print statement in order to see an example of. We've seen 2 times 3 with the star, 2 divided by 3 with a slash. Addition and subtraction are quite straightforward. Powering is 2 stars, so this would be the power 2 to the third. Quotient is the whole part that you get after division, and that takes 2 division bars in order to get the quotient of a number without the remainder or without it turning into a float to include the fractional component. And then the other part of division is the remainder. So the percent symbol in the middle of 2 numbers is the operator to find or return the remainder of that division and not include the quotient. We can run our program and see the evidence of those, and we will in a moment. Each of these operators, that's the symbol that is used to accomplish the math, also has a function that does the same thing. But using the function rather than the operator might be a little more sophisticated than the operator. For example, we could accomplish powering with the pow function. For example, we could write the string power 2 to the third and then accomplish 2 to the third not with the operator star star, but with the function POW for power. And this function requires 2 parts in the argument, 2 and 3, the base and then the exponent. So this function does the same thing as this operator, and each operator symbol has also a function that could do the same thing. More sophisticated math functions come from the math module. We've imported those functions when we did the import statement. And now we can use one as an example. I'm going to print the output of, and then make a print statement so that we can see it amongst all the others. The tangent of 0.8 radians will be printed as the result of using the tangent function from the math module with the endpoint 0.8, which is automatically a measure of radians for that trig function tangent. And 0.8 is a float that we're able to put into that. Notice the module name came first when we used the tangent function, then a dot, and then the function with the input 0.8. So the tangent function is the one that has the parentheses, so we're putting 0.8 into the tangent function. But we also have this math dot in front of it, and that's because the tangent function belongs to the math module, the module being a variety of functions that that comprise a collection under that name math. So if we want access to the tangent function, we need to first use the name of the module that was imported, then a dot, and then the name of the function in that module. We have many more examples of functions being used that come from the math module. Here is math.sine, the sine function. The input is the float 0.8 and it's in radians. This is using the cosine function. The degrees function converts a radian measure into degrees. We have the floor function, which is a rounding function. It does the same thing as round a float down. The integer function does the same thing. If you convert a float into an integer, it floors it, meaning it rounds it down. We have the ceiling function, which is similar to the floor function, but it forces the rounding to go up. The square root function is very useful for most high school math. The log function, though it's spelled log, is actually the natural log function. So the log function is log base e when you use it. And the math.pi and the math.e are not functions. They are constants, they're variables, and they have been defined to be an approximation of pi and e, these very important irrational numbers in mathematics. So you have access to a good approximation in pi and e should you need those values in your programming. We're now going to run the program and see all of these examples in action. We can see in the output that the operators printed the values. One to check is the power, 2 to the third is 2 times 2 times 2, and that confirms to be 8. 2 with 2 division bars 3 is the quotient, meaning the whole part after you divide 2 by 3. 2 divided by 3 is 2/3, or 0.66. So the whole component of that number is 0. The remainder is 2. 2 divided by 3 is 0 with a remainder of 2. There's the remainder operator in action. And then we have kind of a table of the output of using those various functions from the math module. Notice that we have a nice approximation of pi and a nice approximation of e here as defined constants in the module. And the trig values, we must recall, are in radians. So the cosine of 0.8 radians has this value approximately 0.697. And when we converted 0.8 radians to degrees, we had a much more familiar degree measure, about 45 degrees. The math module has many more functions, and there will be more on modules and their functions and how to access them and import our own functions that we write in future lessons coming soon. Now you. You saw how to import the math module and use some of its functions, including trig with radians. Most people are more familiar with degrees. Write a very simple program that outputs the value of a trig ratio given an angle in degrees, which means combining a couple of functions that you saw being used from the math module.